Top 5 methods to finding exoplanets, from most to least successful methods. Number 1 is the transit method, which 4,173 exoplanets have been discovered as of the time I publish this video. The transit method is the easiest method to finding exoplanets, as all it requires is the exoplanet to pass in front of its star, which ever so slightly dims the star's light. Which, as you can see on the chart, the intensity of the light from the star drops. This method can also tell what the size of the exoplanet is by the amount of light observed. If the dimming is lower, the exoplanet is small. If the dimming is higher, the exoplanet is big. It can also tell what the duration of exoplanets' orbit and their atmospheric composition is. Number 2 is the radial velocity method, also known as the Doppler method, with a total of 1,090 exoplanets discovered. When an exoplanet with mass orbits its star, it makes the star orbit outside the center of mass because gravity acts both ways, like how Pluto and Charon orbit. This tugging makes the star wobble. When the star wobbles, we can find out whether the star is moving towards us or further away from us by using a spectrum of colors. The wobble, even if small, can also affect the star's light spectrum. As you can see in this animation, the more blue shifted the spectrum is, the more closer it is to us. The more red shifted the spectrum is, the more further it is to us. To put it simply, radial velocity searches for this wobbly movement. This movement is found by detecting changes in redshift and blue shift of light emitted by a star. If we keep measuring the light, we can find out the star's orbit. This method can also apparently be used to measure the exoplanet's mass and orbit radius. I'll talk about the basics of orbits maybe in the next video. Number 3 is gravitational microlensing, with 217 exoplanets discovered with this method. According to my guy Einstein and his theory of relativity, massive objects warp spacetime, which bends light passing by. This is similar to how black holes bend their surroundings. This method is particularly useful for exoplanets that don't emit their own light, but orbit stars. Number 4 is direct imaging, where 77 exoplanets have been discovered with this method. This is actually one of the hardest methods, as the exoplanet's light would most likely be drowned out by its star's light. There are 2 main methods astronomers use to contradict around this, but I'll only talk about the most common one: coronagraphy. This method uses a device inside a telescope called a coronagraph to block light from a star even before it reaches the telescope's detector, making the exoplanets visible. Number 5 is astrometry, with 3 exoplanets discovered. It's basically radial velocity but without the spectrum. If the target star has moved or wobbled in relation to the other stars, astronomers can analyze that movement for signs of exoplanets. Quite easy to comprehend, but quite difficult to perform, as astrometry requires extremely precise optics, and is especially hard to do from the Earth's surface because its atmosphere distorts and bends light. There are definitely other methods to finding exoplanets which I missed out on, but these are the top 5 most popular ones. Okay, bye.